Okay, hello everyone and welcome to another digital homework video from me, Teacher Jamie. So today I'm going to be describing how we would do a scientific investigation. Are you ready? Okay, let's go. So, this is going to be taken from the Activate Physics books, the intro and part 1.2. So the learning objectives for this topic, you're going to be able to describe how we make a plan for an investigation. Recognize what makes data accurate and precise. We need to trust the information we get. And describe a risk assessment to keep everybody safe. So, not quite science, but we're going to talk about the cake recipe. It's a good example to transfer over to planning the investigation. So when we make a cake, we need to know the equipment needs to make the cake. So mixing bowls, spoons, an oven to bake it in, what the ingredients are. We need to know the process, how to make it. And we need to do everything in the right order, or we're not going to have a very nice cake, or it just won't work. So, let's move on to the actual investigation. Doing a scientific investigation is a bit like baking a cake. We also need to decide what equipment we need to have to do the investigation. Think about what steps we're going to follow and why. Why are we doing it this way? So then we're going to get reliable data and we're going to be able to interpret it. We'll also understand what might be wrong if something is not quite what we want it to be. So when we do any investigation, we need to make sure that the data we get is accurate and precise. So accurate and precise both talk about how good the data is, but they have slightly different meanings. So accurate data. If we have accurate data, it means that the results we have are very close to the true value. So if you look at the picture, all three students will see slightly different values for the length of the paper, because they are looking at it from slightly different angles. So only the boy in the middle is going to see an accurate value, or one that is close to what it should be. Any errors that are seen by the other two students are called parallax errors. If we have precise data, it means that the results we get will be the same if we do them again and again and again. So look at the picture again. All three students will see slightly different values for the length of the paper, but if they swap around, they're going to see the same results as the student before them. So the data is precise. So if we can get the same result in a repeatable way, we have a precise result. But remember, a precise result may not necessarily be accurate. So there we have some examples. If you see, that data has low accuracy, low precision. This data has low accuracy because it's not really where it should be, but it's very repeatable. So we've got high accuracy, but low precision is very close to what it should be, but they're quite spread out. And then finally, everything in the bullseye has high accuracy and high precision. Spread of data talks about how different the set of results are, how different the biggest value is from the small value. So here the spread is quite small, from 5 to 15. Here the spread is big, from 0 to 20. So again, we want as small a spread as possible. Uncertainty. Look at the thermometer. What is the temperature? So somewhere between 0 and 1 degree. We know roughly what it is, but how precise do we want to be? How many decimal places? So there's always going to be a small error when we take a measurement. No thermometer or measuring instrument is perfect, and we have to understand that when we are doing an investigation. Repeatability and reproducibility. In an investigation, we want to know that the data we have is good. So how can we achieve that? Well, just do it again. So if we get the same results or results that are close to each other, we can say the results are repeatable. But is that good enough? No. An important part of science is getting your results checked by someone else, because maybe you are doing something wrong and someone else will find it. So if someone else does the same investigation in the same way and gets the same results, or ones that are close, then we say that are reproducible. So repeatable is you doing it again yourself. Reproducible is someone else doing it. So there are three important types of data. Continuous data can have any value such as length or temperature, including decimal points. Discrete data can only have a whole number, 1, 2, 3, 4, 5. But remember, this continuous data will include discrete data and categoric, describing something with a word such as blue or hot. How many measurements? When you do an investigation, you need to decide the range of measurements you will take. The biggest value, smallest value, and how many values in between, and in what size of steps. And then a risk assessment, always include a risk assessment in your plan for an investigation. Is there anything dangerous you must be careful of? Could anything bad happen? So try to make a plan to make sure everything is safe. So investigation plan should include the scientific question you're trying to answer, the independent and dependent variables, and a list of variables to control and how you will do it. And a prediction. What do you think will happen and why? The list of equipment, a risk assessment, and a plan of how to do the investigation. What steps will you follow? So, quick bit of homework. Copy the sentences down and fill in the blanks. Okay, so that's the end of this video, and I will see you again in the next one. Bye-bye.